Hi, we're going to be graphing today the square root and cube root functions, as well as describing the domain and range of the square root and cube root functions. So let's get started with f of x is equal to the square root of x, and we need to complete the table of values in order to sketch the graph of each function. So I have selected a couple of values for x. Notice that I started with 0 because if I have a negative inside of the square root sign, we are going to have non-real solutions. So I have to start at 0. And then I selected perfect squares because I need to take the square root. So if I have the square root of 0, then we have a value of 0. So I'm going to put my first point at 0, comma 0, which is the origin of my coordinate plane. Then I'm going to select the square root of 1, which happens to be 1. So when x is 1, y is 1. For the square root of 4, that is 2. So I'm going to go 1, 2, 3, 4, and up 1, 2. And then for the square root of 9, I am going to get 3. So if that's 4, 5, 6, 7, 8, 9, 1, 2, 3. And I'm going to make an attempt at connecting these points here. Notice that it's going to be a curve. It's not going to be a straight line, because if I were to draw a straight line, we would not be able to fit all 4 points. And I have the square root of 16 here, but based on my coordinate plane, 16 would be somewhere out of the chart, and for that reason, I'm not going to include this point. But let's try to make a curve that will fit these points. Okay, well, here it is. That's your square root of x function. Okay, now let's talk about the domain. The domain is all the possible values of x that the function can attain. And we already said that we cannot have a negative value. So for that reason, we're not going to have any part of this function on the left-hand side of the y-axis. So here's my y-axis. Oops, did not mean to do that. Here's my y-axis. And as you can see, not a single part of that function is on the left-hand side. So for that reason, the domain has to be x is greater or equal to 0. Well, what about the range? Well, I have all positive values here. So for that reason, I cannot have a y value that is negative. So y has to be greater or equal to 0. So as you can see, we're going to be graphing the square root of x function only on the first quadrant. And this is a parent function. So what happens when we start to translate this function? Let's look at an example. Here we have f of x is equal to the square root of x minus 2. So this is going to be a translation on the x-axis. So what happens is, since I have to take the square root of x minus 2, I need to first figure out what the domain is going to be, to figure out the values for which the square root of x minus 2 is going to be greater than 0, because that's going to restrict us from getting a negative inside of the square root sign. So our radicand needs to be greater than 0. So let's take a look. We're going to say x minus 2 has to be greater or equal to 0. That means that x has to be greater or equal to 2. So that's our first restriction on the domain. So I can start out by writing my domain restriction. Okay, so my very first point is going to be at x is equal to 2. So I am going to select x is equal to 2 and evaluate it. So the square root of 2 minus 2 is equal to 0. So when x is equal to 2, y is equal to 0. Now notice that for this graph, I am counting by 2 on the x-axis, and on the y-axis, I'm counting by ones. Okay, so I know that my other perfect square is 4. Well, what value must we have here for x in order to get the square root of 4? That has to be 6, because 6 minus 2 is 4. So the square root of 4 is going to be 2. But that happens when x is equal to 6. So now I am shifting this graph over to the right-hand side. The next perfect square is 9. What value must we have in the radicand in order to have the square root of 9? Well, that has to be 11. 11 minus 2 is 9. The square root of 9 is 3. So 11 is going to be here, somewhere in between, and I am going to put my point here. Okay, now with these 3 points, I can do a quick sketch of my square root function, the square root of x minus 2. I'm going to attempt at connecting these points. And I'm going to have an arrow because this function can continue. Now, what are the possible values for the range? Well, again, my lowest point, my minimum point is at 2, 0. So my function is not going below the x-axis. For that reason, y can be greater or equal to 0. Okay. So as you can see, we shifted this square root of x function over 2 units to the right.